Yes, I will present our work at the University of British Columbia, done with Cristina Conati. So the basic idea is that more and more users are using our visualization for many different reasons, context, task, etc. But still, visualization are often designed in a one-size-fits-all approach, meaning that the same visualization is provided to everyone. And this despite of the fact that there's evidence that not everyone can actually process visualization in an effective way. And it has been shown to depend on for instance, on the user's individual differences, such as their cognitive abilities, their personality, their interests, their preferences, etc. And so this impact of individual differences on visualization effectiveness has been shown for plenty of visualization. And I just show a small subset here on this slide with bar charts, maps, or more elaborated visualization. So this finding suggests that people could benefit from personalized visualization that could be more suited to their user differences, to the level of individual differences. And one key question here is, how do we personalize visualization? Traditionally, there are two approaches. The first one is just let the user customize it the way they want with interaction features. And the other one is let the system adapt the visualization automatically and dynamically, like in the back. And so both have been studied a lot in HCI studies, and they both have pros and cons. Typically, customization, they let the user in control of the personalization, but we know that not everyone customizes in an effective way. Adaptation can be provided to everyone and can be effective, but also to some users it can look intrusive, opaque, or the typing can be off, etc. So there have been a third approaches that have been studied by combining customization and adaptation to try to combine them pros and reduce the cons. One very famous example is mixed initiative interface, where the system suggests ways to personalize, but it's up to the user to accept or not these recommendations. So ultimately, the user is in control. So this talk fits more in these third approaches, combining adaptation and customization for information visualization. And our idea is to actually explore whether it could be useful to actually provide user adaptive support to customize. So the idea is as follows. First, we want to understand whether and how individual differences impact how people use and benefit from customization in visualization. So an example of individual differences in that case is cognitive abilities. And if we can find an impact, then the idea would be to leverage this into adaptive visualization to provide adaptive support to customize. So a couple of examples. For instance, we could enable customization only for users who can benefit from it based on their level of, for example, cognitive abilities or experience, and disable the customization for the users who we know may not benefit from it. Or second bullet, we can recommend customizing to these users if they don't do it spontaneously, again, based on their cognitive abilities, etc. And another example of recommendation could be adaptive prompts, such as, hey, we think you may benefit from customizing, why don't you give a shot? So the idea here is to essentially provide adaptive support for customization with the user still being in control at the end of the day of the personalization. So in this paper, we focus on the left part of this framework, so trying to understand if and how individual differences impact customization in visualization. So specifically, we investigate the impact of two types of individual differences, cognitive abilities and personality traits, because there's already evidence that they both matter in visualization, and they may impact how people benefit from our mechanism. So on customization, behavior, and effectiveness. And we do that with MetroQuest, which is a commercial visualization-based system for public engagement. So I will explain a bit more how it works. So for this talk, I will first talk about MetroQuest and how to provide personalization. Then I will describe the user study and the analysis, and then the results and conclusion. All right, so I will first show you a video of how MetroQuest works.
The MetroQuest interface is designed to guide the user through the process of learning and comparing 3 proposed transit scenarios in the city of Vancouver. Screen 1 welcomes the user and provides background information about the overall transit project. Screen 2 helps users select and prioritize which indicators will be used to compare the different transit scenarios. Here, the user selects travel time savings and cost as two of the indicators they feel are important. Screen 3 allows the user to learn about each transit scenario using two different visualizations. First, on the right, a deviation chart shows a visual summary of the values of all the indicators. The prioritized indicators selected during Screen 2 are displayed at the top. A green arrow indicates that travel time savings will be improved, whereas the red arrow indicates that cost will get worse. Second, a map on the bottom shows the proposed transit route. The indicators are also plotted on the map. For instance, travel time savings are shown as numerical values at various stops along the way. In practice, the user can compare the three scenarios by switching among the three tabs shown at the top. The user can also provide a rating out of 5 stars for each scenario.
All right, so we focused on MetroQuest first because it's an actual system that has been deployed and tested a lot in North America for plenty of different public engagement projects. So the video showed a project we implemented with the company for the transit project of the city of Vancouver, but it's been deployed for plenty of other public engagement projects in many states or cities. And we also conducted a first study with MetroQuest with 166 participants. And we found in this study that several cognitive abilities impact the user experience, satisfaction, preferences with MetroQuest, and the two visualization. So this provided preliminary evidence that people may benefit from personalization in MetroQuest. So the specific mechanism we evaluate here for personalization is allowing the user to customize the information content in the interface by hiding or displaying one of the visualization at will. So this is done with the two green buttons here, hide map, hide chart. The user can click them to remove one of the visualization, and of course they can bring it back whenever they want and repeat this process. So why do we think this could be useful? First, in the first study, we found that depending on the cognitive ability of the user, some perceive one of the visualization are not useful compared to the other. So the idea here would be to allow them to remove the visualization they don't like so that they can focus on the preferred visualization and thus work on an interface that is more suitable to their preferences. Another is that comparing visualization across the scenarios, we found that it can be challenging to some users, again, depending on their cognitive abilities. And so by removing one visualization, it might be easier for users to actually make comparison by focusing just on comparing one visualization rather than comparing the two at the same time. All right, so we conducted a new user study with 46 participants who were recruited among the target community of the transit project in Vancouver. Just to clarify, this is an actual public engagement project studied by the SIGCHI, and people are well aware of it because it's been covered by the news. So people are probably likely to have an interest in this project. The task was to rate each of the three transit scenarios that you saw in the video using these stars. It's a 5-point Likert scale, essentially. On average, it took 4.5 minutes to provide the ratings, but they received no training with MetroQuest and no time constraint because this is how MetroQuest is used in actual settings. People, they have as much time as they want. After that task, we provided a questionnaire so that users can report their experience with MetroQuest. We collected a variety of individual differences, and we also used the Tobii eye tracker to collect the user's gaze, and I will explain a bit later why we did that. So to evaluate the impact of individual differences on customization, we measured 7 individual differences, 5 cognitive abilities on the top, and 2 personality traits. So we have, in order, perceptual speed, visual working memory, spatial memory, visual scanning, visualization literacy, extroversion, and locus of control. So I will provide definition later on for the differences for which we found effects, but you can find all the definition in the paper. I just want to keep it simple here. But the idea essentially, we pick those individual differences first because for the cognitive abilities, we already know that they influence user experience with MetroQuest. We measured that in our first study with the 166 participants. And in general, we also know that it can impact user performance with other visualizations. So there have been lots of study on these particular cognitive abilities. And for personality trait, it also could influence the willingness of the user to customize. So we measured those two personality traits because we felt they could impact whether or not user would be likely to customize, to use a customization mechanism. So for the dependent measure in the study, so here one problem is that because the task is purely subjective, there's no measure of performance. In particular, there's no right or wrong ratings in this task, and also the time is not important because it's okay to take more time if the user provides better ratings at the end of the day. So instead, we measure three measures of user experience. The first one is confidence, self-reported by the user on a Likert scale. The second one is the decision coherence. So we leverage the rankings provided by the users, as shown on the right, to understand whether it the ratings they provided to the scenario matches the priorities. So here, for example, the top priority for this user is physical accessibility. So we expect this user to provide high ratings to the scenario that improve physical accessibility the most. And third is the amount of visual comparison across scenario measured with an eye tracker. So if you remember in the video, we show that switching between tabs is a way to see the difference among the visualization and the trade-off across the scenarios. And this is a key feature in MetroQuest to understand what are the trade-off and what is at stake with those scenarios. And the more comparison usually means that the user takes time and effort to try and understand the trade-off. And so we use an eye tracker to see how many times they tabs while still watching at the visualization. So we run a regression analysis with the three dependent measures as the three measures of user experience for the dependent measures. The independent variable is whether the user customized or not, and the covariate is the individual difference. So we run one regression for each of the 7 individual differences, and we run some post-hoc pairwise comparison with adjustment. All right, so for results, I will first show a bit of the data about customization and then report the two effects we found of visualization literacy and locus of control in the statistical analysis. So first, we found that 15 participants customized at least once. As shown on this chart, they did it mostly to focus on the map. So here, this is the proportion of time spent processing the customized interface. Blue means there were no customization, so the two visualizations were displayed. And green means only the map or the chart were visible. So the user was working with a personalized interface. And you can see that in proportion, users mostly, when they use a customized interface, it was to focus on the map. And so even though only a minority of users customized, because the task was very short, only 4 to 5 minutes on average, it's still interesting to see that some people try to leverage the customization mechanism. And then, so the first effect we found is of visualization literacy on a number of visual comparison made. So what we can see is first people with high visualization literacy in orange on the chart, the orange line, they made much more visual comparison when they customized on the left and when they did not customize on the right. And this is the opposite for users with low visualization literacy. They made less comparison when they customized than when they did not. So this suggests that high visualization literacy is important to take advantage of the customization mechanism. And in terms of adaptive support, it means that when those high visualization literacy users do not customize spontaneously, we could provide adaptive support or prompts to encourage them to do that because we know that they could benefit from it. And for the other people with low visualization literacy, because they did not benefit from the customization mechanism, they could be provided with another way to personalize the interface, maybe, for instance, prompt or cues to perform more visual comparison in this case. And the second effect we found is of locus of control on confidence. And so what we found is that users with an internal locus are more confident when customizing than when not customizing, so the orange line. And people with external locus, it's the opposite. They were less confident when customizing. So having an internal locus means that people believe they're in control of events happening in their life. And so somehow this seems to suit the belief here. When they customize, they were more confident, so it kind of suits the belief that they're in control, and maybe they like it. And again, if those internal locus of control people do not customize spontaneously, we could recommend them to do it with adaptive support or prompt, because we know that it might boost their confidence. And for the other user with an external locus, possibly they don't like to be in control of the interface, or they don't believe, they don't trust this system, and they may prefer adaptation delivered at the system initiative, for instance. So to conclude, we found a relationship among two individual differences, customization effectiveness and user experience in a visualization-based interface for public engagement. And the implication of this is that the users in general might benefit from adaptive support to customize visualization. For instance, we could encourage the users who could benefit from it but do not do it spontaneously to customize, as I was mentioning, depending on the level of visualization literacy or locus of control. And some feature work to finish. So one, we want to further examine when customization was the most effective, because the Measure Quest interface requires several subtasks, like understanding the visualization, provide the ratings, revise your ratings. And it's possible that customizing is the most useful to some of the subtasks, and this will provide information about when we could dynamically provide adaptive support to customize, for instance, during the subtask where customization could be the most effective. We want to implement and test some of the adaptive support we had in our results suggested. And finally, we want to understand if these results can generalize to other visualizations. So thank you.
Yes, Peter. Yeah.
Hello, thanks for interesting results. Peter Busilowski, University of Pittsburgh. I'm challenged with the practical application of that. You use a lot of questionnaires and standard tools to find that individual differences. And how we can do it in the real scenario? It looks like by the behavior is very hard to say, because people in both groups choose customization, right? One of them did it for a good reason, others, as it appears, made a mistake. But so by the behavior, we can't figure it out, and it's probably unrealistic to give questionnaires. So we can adapt, but how we can do it in real life?
Yeah, so it's an excellent question. It's actually one of the reasons we had an eye tracker in the study is because in other part of this project, we use eye tracking to predict or detect what are the level of individual differences of the user. So your cognitive abilities and your personality. And result we found is that after only a few seconds of eye tracking data collected, usually 10 to 20 seconds, we can predict some of the cognitive abilities with rather high accuracy, around 70%, more or less. And this is ongoing work, but the idea for us would be to use eye tracking data to make prediction of the personality and the cognitive abilities. We also have been doing a bit of work on using also mouse interaction data to predict the same type of information, and also mouse data are not as informative as eye tracking. We can still make prediction around 65% accuracy as for what is your personality and your level of cognitive abilities. So that's how we plan, that's our idea to provide this adaptation mechanism.
Another question? Oh, yes.
Hi, Alvita Otley from Washington University in St. Louis. Interesting work. I really like that you're using a real-world scenario here. But I'm curious about, so you said one of the future work is looking at replicating this with other visualization systems. I'm curious about your thoughts in terms of how this task or this visualization or what people did can transfer to more general visualizations.
Yeah, so first of all, the two visualizations we use, the map and the chart, the deviation chart, are extensively used in a lot of MetroQuest work for engaging public. And they have found that these are robust visualization. And also the MetroQuest companies have also experience with a few other visualization, still in the same context for public engagement and engaging different people. So the idea for us would be possibly to investigate either on other public engagement tasks, the same visualization, the map and the chart, or also leverage other visualization. But the point is, in this context, we just focus on visualization that are widely used for public engagement into the world.
Just quickly add to that. So a context where this type of customization can be relevant is in dashboards, where often different visualizations are used for conveying the same information. And so we have been in touch with people working on dashboards to see if that could be something that could be tested there, right? Because users may be deciding to only see one or two of the visualizations instead of all the data at once. So that's another example.
Yes. Any more questions? Okay, I think this would be the last one. Okay, some good exercise, huh?
Hello, I'm Jordan Barria Pineda from University of Pittsburgh. I wanted to ask you if the visual literacy questionnaire or the construct that you use for your research includes how people is different when they make decisions using the visualizations, because as far as I understand, visual literacy means like how they are able to understand charts, but also I think it's different how people use those charts for making decisions. So for example, some people could maybe focus on only the higher difference between the two things that they are comparing, or maybe there could be other approaches. So I wanted to know if you had that part, or you evaluate that in your visual literacy measurement.
So not in this particular work, but we have other work in which we use eye tracking to understand what is the strategy of the users, of different users when they look and work with visualization. And typically we do that by comparing people with high or low levels of cognitive abilities, and we try to see if there are differences in the gaze attentional patterns about the visualization. And this can inform us about what is the strategy of different groups of users and how they process. But this was not part of this project, yes.
Okay, so let's thank all the speakers of this session again. Okay, good. Yes. Okay, so, okay, and now it's coffee.